Hi everyone, my name is Ravi Prakash and we are into a different topic now, finding divisibility rules and remainders first class, right? So we have done all the basics of remainders earlier, applying Euler theorem, Chinese remainder theorem, reverse Euler theorem, right? Positive remainder, negative remainders, Wilson's remainder theorem, digital sum, everything we have done, right? In the previous videos of remainders. Now we'll apply divisibility rules of some numbers with the remainders. Okay, now let's find out divisibility rules with remainders. Okay, now let's see for finding this divisibility rule, we'll first uh, get this concept. Okay, any number of the form ABC. Now ABC here is a 3-digit number, so any number of the form ABC, that 3-digit number can be written as 10 square A plus 10 raised to 1B plus 10 raised to 0C. That is 100A plus 10B plus C. Right? We have discussed this earlier also. This is ones place, this is tens place, this is hundreds place. So ones place 10 raised to 0, tens place 10 raised to 1, hundreds place 10 square. Why? Because a number like 567, right, can be written as ones, tens, 100, right? So 5 into 100 plus 6 into 10 plus 1 into 7, right? So always each digit multiplied by its place value. This is how we write. Okay, even if it is a 5-digit number, A, B, C, D, E, now it is a 5-digit number, suppose. So in this case, again starting, what is the last power of, if it is a 5-digit number, so we'll start with A. So A should be what? It should be 10 raised to 4, because if it is a 5-digit number, last will be 10 raised to 0. So that last digit, that first digit will be what? 10 raised to 4. For 5-digit number, 10 raised to 4. For 3-digit number, 10 square, always one less, right? For 5-digit number, 10 raised to 4. So 10 raised to 4 into A plus 10 cube B plus 10 square C plus 10D plus E. 10 raised to 0 is E, right? This is how we can write all these numbers. Fine. Okay. Now we'll find the divisibility rules based on this logic. Okay, based on this logic. Let's find out. Okay, let's find out. Now see here. If I have to find divisibility rule for all the numbers of the form 2 raised to n and 5 raised to n, 2 raised to n and 5 raised to n. Okay, numbers of the form 2 raised to n and 5 raised to n, right? Most basic. See, a number, suppose A, B, C, D, E, F, suppose it is a 6-digit number. Okay, how do we write it? We write like A into 10 raised to 5 plus B into 10 raised to 4 plus C into 10 cube plus D into 10 square plus E into 10 raised to 1 plus F into 10 raised to 0. Okay, now suppose this is a big number, right? A, B, C, D, F. So now this A, B, C, D, E, F 6-digit number, I'm dividing by 25. Okay, this I'm dividing by 25 now. So it's a 6-digit number, I'm dividing by 25. So dividing by 25 and getting the remainder. Okay, so dividing by 25 and getting the remainder. Fine. See, now what will happen here? 25 is nothing but 5 square. Okay, now leave out all the digits here. A, B, C, D, E, F, leave out, right? So apart from A, B, C, D, E, all such number will have this number in common, like 10 raised to 0, 10 raised to 1, 10 square, 10 cube, 10 raised to 4, 10 raised to 5. Okay, now once you divide by 5 square, so 1 by 25 will be, remainder is 1 only. Okay, so here we'll get some remainder. Okay, 10 by 25 will get some remainder, that is 10. Okay, so here also we'll get 10 remainder. Now 100 by 25, what is the remainder? 100 by 25, what is the remainder? Remainder is 0. 100 by 25, remainder is what? 0, right? 0. That means this part remainder is 0. Okay, 1000 by 25, what is the remainder? Again 0, because 1000 is completely divisible by 25, 0. Similarly, 10 raised to 4 by 25, right? So all the further powers, this remainder will be 0 only, because all the powers after 10 square are divisible by 25, because all those powers contain what? It contains 5 square. What is 10 square? So 10 square is nothing but 2 square into 5 square. What is 10 cube? 2 cube into 5 cube. What is 10 raised to 4? 2 raised to 4 into 5 raised to 4. What is 10 raised to 5? 2 raised to 5 into 10 raised to 5 raised to 5, right? You see here, so after 10 square, from 10 square, every number contains at least 5 square. That means this will completely cancel. What is the remainder? 0. Okay, so what we are left? What we are left with? We are left with 10e plus f. That's it. So 10e plus f is what? Is the last 2 digit, can be written as ef only. Because what is ef? ef is what? 10e plus f. One sentence digit, right? So normally we write ef. Mathematically we write 10e plus f. Okay. This is what is the ef? This is the last 2 digit of the number. Okay. Now similarly, if you assume this as, suppose it was instead of 25, it was, suppose it was 5, 4, or it is 2 square. In that case, what would have been left? Again same thing, because 1 by 4 some remainder will get, 10 by 4 some remainder I will get, but 100 by 4, what is the remainder? 0. 1000 by 4, what is the remainder? 0. Now after that each term will be 0, because every term contains at least 2 square. From here onwards, every term contains at least 2 square, right? So all the remainders are what? 0. Okay. So again I'm left with same thing, that is ef only. That is the last 2 digit, right? Very important thing we're discussing here. Last 2 digit. Okay. Now understand. Next, one more example we'll do, and then we'll generalize. Okay. Now suppose it is like, again, if a number is again a, b, c, d, e, f, again it's a 6-digit number, I should write again like a into 10 raised to 5 plus b into 10 raised to 4 plus c into 10 cube plus d into 10 square plus e into 10 raised to 1 plus f into 10 raised to 0. Now suppose this whole big number, suppose this big number is divided by 8. What is the remainder? 8, right? Now what is 8? 8 is nothing but 2 cube. Okay. So if 8 is 2 cubes, again you see this 1 by 8 you will get some remainder, 10 by 8 you will get some remainder, 100 by 8 you will get some remainder, but after that 1000 by 8, what is the remainder? 1000 by 8, what is the remainder? 0. 10,000 by 8, what is the remainder? 0. All become 0. Why? Because after this every term, see this term contains 2 raised to 5, 2 raised to 4, 2 cube. So after this every term contains a 2 cube, right? So 2 cube will completely cancel. What is the remainder? 0. So what I am left with? I am left with 100d plus, let me write clearly, 100d plus 10e plus f. Okay, 100d plus 10e plus f. That is what? That is nothing but DEF. That is a 3-digit number. DEF is a 3-digit number. On breaking it, we write 100d plus 10e plus f. Okay. So what is this? Is left with last 3 digit. What we are left with last 3 digit. I'm left with a number. Last 3 digit, right? So A, B, C, D, E, F, we are left with last 3 digit. Similarly, if I divide instead of 8 2 cube, I can also divide by 125, that is 5 cube. Again same thing. 1 by 125, I'll get some remainder. 10 by 125, I'll get some remainder. 100 by 125, I'll get some remainder. But after that, all will be 0. Why all will be 0? Because now after that, each term contains a 5 cube. See here onwards, each term contains a 5 cube. So 5 cube will completely cancel. What is the remainder? Remainder is 0. Right. So what I am left with? Still I am left with DEF. That is the last 3 digit. Right. So now get this pattern in mind. If there's a big number, right, it doesn't matter now, because if it is 0 here, it can be further 0 before 5 and 6 digit number, right? It could be 6 digit number, it could be a 10 digit number, 20 digit number, 100 digit number, right? After this, after c into 10 cube, all becomes 0, right? So that basically means that if I'm dividing by 25 or 5 square, I have to only look at last two digit, or 2 square. 2 square or 5 square, only last two digit. 2 cube or 5 cube, only last 3 digit. So 2 cube or 5 cube, last 3 digit. 2 square or 5 square, last 2 digit. Therefore, I can generalize that for 2 raised to n and 5 raised to n, I have to only look for divisibility for last n digits. Divisibility for last n digits. That's it, right? That's it. For example, if it is 2 raised to 0, 2 raised to 1, 2 square, 2 cube, 2 raised to 4, so on. 5 raised to 1, 5 square, 5 cube, 5 raised to 4, so on, right? This will take care of all these numbers. It will take care of all these numbers, right, fully. So for example, if I write here 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 125, what is the remainder, right? So I should simply check that. What is 125? 125 is nothing but 5 cube. So for 5 cube means for 5 raised to n, it is last n digit. So for 5 cube, it is last 3 digit, right? I simply have to check for last 3, that's it. Or because all will become 0. So just I'm left with what? I'm left with just 789 by 125 remainder. So 125 into 6 is 750. So what is the answer? Answer is 39. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 125. What is the remainder? Remainder is 39. That's it. Okay. So 125 means 5 cube. I'm looking for just last 3 digit. Okay. Very simple. Very simple it is. Okay. 3, 4, 7, 8, 2, 9 divided by 4. What is the remainder? So now what is 4? 4 is just 2 square. So 2 square means I have to just look for last 2 digits. I have to just look for last 2 digits, right? So only last 2, 29. What is the answer? Answer is 29 by 4. 4, 7, 8, 28. What is the answer? Answer is 1. So 1 is the answer. That's it, right? So 3, 4, 7, 8, 2, 9 divided by 4 remainder. What is the answer? Answer is 1. Because for 4, I just need to look at last 2 digits. Because what is 4? 4 is 2 square. Any number of the form 2 raised to n and 5 raised to n, I have to only look for last n digits for finding remainder or divisibility rule. Okay. So whenever we ask that, suppose I can be asked that, okay, if a number is divisible by 4 or not, is this number is divisible by 4 or not, right? So what we will do, we'll directly calculate the remainder. We will directly calculate the remainder. If remainder comes out to be 0, it is divisible. Otherwise, we'll get the remainder. Okay. So whenever asked about divisibility, we'll simply calculate the remainder. Fine. Okay, so this takes care of all the numbers. Okay, all the numbers of the form. Okay, all the numbers of the form 2 raised to n and 5 raised to n. What is the rule? Check for last n digits. Check for last n digits. That's it. That's it. Okay. Now next I'll look for, we've done this. Okay, next I'll look for divisibility rule for 3 and 9. Right, 3 and 9 rule will be same because 3 is a factor of 9. 3 is a factor of 9. Okay. Now see, again take example. Take example A, B, C, D, E is a 5-digit number, is a 5-digit number. Okay. I can break like A into 10 raised to 4 plus B into 10 cube plus C into 10 square plus D into 10 raised to 1 plus E into 10 raised to 0. Now, if I am dividing this whole number by 9, what is the remainder? You see, now again you look at only 10, right? 1 by 9, okay? 1 by 9, remainder is 1 only. 10 by 9, remainder is 1 only. 100 by 9, remainder is 1 only, right? Because 10 into 10 by 9, what is the remainder? So by this property of remainder, we can do it individually. So 10 by 9 remainder 1, 10 by 9 remainder 1. So 1 into 1 is 1 only, right? So it is 1. 10 cube by 9, again 1, because if I add one more 10 here, no issue. 10 by 9, again 1. Okay, so 10 cube by 9, 1, 10 4 by 9, 1. It doesn't matter, right? Whatever be the power of 10, any power of 10 divided by 9, what is the remainder? 1 only. So what I'm left here now? So after dividing by 9, what I'm left here is, I'm left with a plus b plus c plus d plus e, right? So this I'm looking for. If this number has to be divisible by 9, right, this means on dividing by 9, that remainder has to be 0. So if remainder is 0, then only number is divisible, obviously, right? So what we'll do, that's why the rule for 9 is what? A plus b plus c plus d plus e. That is what? That is sum of the digits. That is sum of the digits. So rule for 9, 3 and 9 is what? Check for the sum of the digits, because all the powers of 10 when divided by 9, remainder will be 1. Okay, so only check for the sum of the digits. Fine. For example, 7 9 8 6 5 4 8 9 divided by 9, what is the remainder? What is the remainder, right? Simply what we'll do, we'll simply check for sum of the digits, right? 7 plus 9 16 plus 8 24 plus 6 30 plus 5 35 plus 4 39 plus 8 47 plus 9 56. So 56 by 9 remainder. So 9's again I can add, right? Again I can add digits. So 5 plus 6 11. So 11 by 9 remainder. What is 11 by 9? 2. So 2 is the answer, right? So 2 is the answer, because 11 by 9, what is the remainder? Remainder is 2. Okay. So for 3 and 9, I have to always check for what? I have to always check for sum of the digits. For 3 and 9, I have to always check for sum of the digits. Okay, clear? Okay, next we'll do for 11. Next we'll do for 11. Now, divisibility rule for 11 we'll do for 11. Okay, now see, for 11, what will happen now? Take say number ABCD is a 5-digit number. Now this number I am dividing by 11. This number I am dividing by 11. Now what will happen if I divide by 11? You see here now. What will happen if I divide here by 11? See, in this case, negative remainder will come into picture, right? When divide by 11, negative remainder will come into picture, right? Because 1 by 11 remainder is 1 only. 10 by 11, what is the remainder? Minus 1. 100 by 11, what is the remainder? Plus 1. 1000 by 11, it is how much? Minus 1. 10,000 by 11, it is how much? Plus 1, right? It is minus 1, no? Because 1000 by 11, 10 into 10 into 10 by 11, remainder I am calculating, right? So minus 1, minus 1, minus 1, it is minus 1 only. So 10 cube by 11 is minus 1. So in short, any even power of 10 by 11, remainder is plus 1. Any odd power of 10 by 11, remainder is what? Minus 1. Okay. So what we got result as here? We got result as, from here, we got result as, there are this negative signs, right? E plus E, E, C and A are of positive sign. E, C and A are of positive sign. D and B are of negative sign. D and B are of negative sign, right? So we can consolidate like E plus C plus A minus C plus, sorry, E plus C plus A minus D plus B minus D plus E. Now this should be dividing by 11. The remainder should be how much? The remainder should be 0, right? So this should be either in terms of, for this to be divided by 11, the remainder should be 0. Okay, so for this number should be either 0 or a multiple of 11. Okay, so rule for 11 goes like this. So rule for 11 goes like this, right? Starting from last, sum of digits at odd places minus sum of digits at even places. This is the rule for 11, right? Starting from last, that means last I have to count as 1. So start some of the digits at odd places, right? Odd places. 1, 3 and 5 minus sum of the digits at even places, that is 2 and 4. Now this should be either 0 or of the form 11k, because if it is of the form 0 or 11k, then only by dividing by 11 I'll get remainder as 0. That means number is divisible by 11. Okay, so for 2 raised to n and 5 raised to n, only we'll check for last n digits. For 3 and 9, we have to check for sum of the digits. That means sum of the digits should be divisible by 3 or 9. Divisible by 3 or 9. Okay, and for 11, this is the rule. This is a rule for 2 raised to n and 5 raised to n. All the numbers like 2, 4, 8, 16, 32. Okay, and powers of 5 like 5, 25, 125, 625. Then 3, 9, 11. This we have discussed. Till now. Okay. Now we'll do a question now. See, question 1, 2, 3, 4, 5, 6, 7. This is written till 634 digits. Till 634 digits. Okay. Let it be n. Okay. We write like this is n. So n is equal to this much. This is a question. N divided by 32, what is the remainder? N divided by 32, what is the remainder? Okay, let's solve it. So n is a big number, huge number. 1, 2, 3, 4, 5, 6, 7, 8 till written till 634 digits, right? So n divided by 32, what is the remainder? So first you should focus on this. N divided by 32. So 32 means what? It is 2 raised to 5. That means I am only concentrated on last 5 digits of this number. I am only concentrated on last 5 digits of that number. This number, right? This number, last 5 digits, because any rule, divisibility rule for any number of the form 2 raised to n and 5 raised to n is what? Last n digits. That's it. Okay. So 2 raised to 5 is what? Last 5 digits. 2 raised to 5. So how to count digits now? See, how to count digits I'll tell you. See, simply we can count simply 1, 2, 3 till 9. We can count 9 digits. Then 10, 11, 12 till 99. Now each number has got 2 digits, right? Each number has got 2 digits. So there are 90 numbers here. Okay, there are 90 numbers here. So each number has got 2 digits. So how many digits in total? Total 180 digits. Okay, so that means if a number is written like this, 1, 2, 3 till 99. Okay, so in total 189 digits are written. Okay, now if 189 digits are written here, so what you have to find? You have to find for 34 digits. Okay, so if it is for 634 digits, right? So how many are left now? 634 minus 189. That is how much? That is 445. 445. So 445 are left. Okay, so now each digit will contain 3 digits. 100, 101. So each number will come 3 digits. Each number will contain 3 digits, right? Like this it will go on. So we have to just see, right, till which number it will go in multiples of 3, because 445 is not a multiple of 3. Okay, so since 445 is not a multiple of 3, so till which number it will go? Right? So since 445 is not a multiple of 3, till which number it will go? Okay, so till which number it will go? You can calculate 445 by 3. What is how many times it goes? So 445 by 3, it goes how many times? You can just simply calculate 445 by 3. So it's like 148 into 3 is 444. Okay, understand this? 148 into 3 is 444 plus 1. Okay, very important concept, very important, how to count digits. Okay, so 634 digits are here, 634 digits in total. If 1 2 3, that means all the 9 single digits and then all the two digit numbers are written, then 9 plus 180, total 189 digits are counted if it is from 1 to 99 written, right? Now after that it starts 3 digit number. Okay, so each number it contains 3 digits. So you have to go for how many digits now? Total 634 digits, 189 already over. So you're left with 445 digits. Okay, so 445 by 3, because each number contains 3 digits, is what? 148 into 3 plus 1. That means I can write 148 numbers like this. So starting from 100, 148 number will be how much? 99 plus 148, how much? It is 247. Okay, so 99 plus 148 is how much? It is 247, right? 247. So like this, 333 148 times. Okay, 333 digit in 148 numbers. This will count for total 244. Sorry, this will count for, okay, so this will count for total how many numbers? This will count for total 148 into 3, total 444 digits it counted for. So we're left with only one now. So after 247, 248, but afterwards it is not needed, right? Afterwards it is not needed because it is how much? 248, right? So 2 and then it starts with 48, right? So this part I'm not considered because that's it. My 445 digits are 441 plus 1, 445 digits and plus 189. 634 are over. Total 634 are over. So in that case, how much is left now? So what is the last 5 digits of the number? 247. Now here it is 246. So last 5 are 62472. Okay. Last 5 are 62472. So last 5 are 62472. So we are searching for last 5 digits only. So 62472 divided by 32 remainder. How much it is? Do it manually. Okay. 32 1 is 32. 304. So 32 into 9 is 288. So again 16. 107. So answer will be 8. So 8 is the answer for this question, right? So basically the question was 1, 2, 3, 4, 5, 6, 7 till 10, 634 digits. Okay. What is the remainder when this n is divided by 32? So when n is divided by 32, in that case 32 means what? It is 2 raised to 5. So what I need? I need only last 2 digits. Okay, I need only last 5 digits. I need only last 5 digits, right? So we have counted last 5 digits. That's it. In the whole question, we have counted last 5 digits. How to do it? So 1 to 9, 9 digits. 10 to 99, there are 90 numbers. So each number 2 digits. So 180 digits. So 180 plus 9, 189. Now we are left with further how much? We are left with further 445 digits. So 445 digits we are further left with. 445. Now after that, each digit has 3 numbers. Each number has 3 digits. So 445 by 3. It is how much? 148 into 3 plus 1. That means each number has got 3 digits. So 148 numbers from after 99. So 99 plus 148 is how much? 247. Okay. And here 444. 148 into 3 is how much? 444 digits. So still 1 is left. So after 247, one more 2 will come. That's it. Now my over. 445 are over. 445 plus 189. 634 over. So numbers are written like this. 246, 247. At 2 it is getting over, right? What is my last 5 digits? 62472. 62472 divided by 32. What is the remainder? Remainder is 8. An absolutely super question. Okay. So just try it 2-3 times. How to count digits. This is purely aptitude, right? Very good question. Try it for 2-3 times. You will get it. Okay. Thank you.